This is New Era Systems. Today I'm going to run over the quick test of an MT3200 400 watt KU-Band amplifier. Before testing any amplifier, the most important aspect is to make sure that the RF flange on the back, the output, is properly terminated. In this case we're using a dummy load. The dummy load absorbs all of the radiation being sent out during the test. There are two ways of testing the output of an amplifier. You can go to the front panel display and accept the reading on that, which is not always 100% accurate. Or what we prefer to do is to connect something called a cross-guide coupler. This coupler gives an output port or a monitor port for an HP power meter. This is the HP power meter. It has no input at the moment, and so the front display is just oscillating. But it's set to display once, and this Agilent signal generator is what I'm going to use to generate the input frequency and power to test the output of the amplifier. I have two amplifiers on the bench. The top one has been tested before and it shows a failure. So I'm going to go ahead and start this one so I can demonstrate that not everything we have works immediately. In this particular case, this top amplifier is not available for resale. When the amplifier is first started, it will not transmit until it goes through approximately 6 minutes of power up and warming the tube. Filament display shows 290 seconds. We'll get back to this as soon as it's ready to transmit. While I'm waiting for the amplifier to warm up, I've set the signal generator to 14,500 megahertz. This is the top range of that particular amplifier. I've decreased the power on the output to negative 41, which is low, and it's not likely to generate anything in the way of output at this stage. So we always start off with a low input and then gradually work it up. We've gone through the warm-up period, so now I'm going to set it on to transmit. As you can see, there is 0 watts being output. We're looking at the milliamps. The milliamps to the right, fluctuating between 1.8 and 1.7, is quite high because there is no drive, and we would expect to see it far lower than that. This is an initial indication that this particular amplifier does not have a good tube. So now I'm going to go over to the frequency generator and start to increase the power at the same time watching the output on the amplifier. So we're minus 23, minus 15. I'm not going to take it any higher than this at the moment until I check on the gain. The gain is set at 95% on this amplifier. Now I'm going to gradually increase the gain and initially just watch the output on the monitor of the MT3200. The first thing to note is that the milliamps shown at 1.8 is pretty high because there's virtually no input at this stage. In fact, there is no input. And so that should be considerably lower. This is the first indication that we may have a problem with this. Okay, so now I'm going to go to the frequency generator and start to increase the power. So we're showing 1 watt. And I'm going to step it up to about 150 watts and look at two things. First thing I want to see is where those milliamps go on the tube. Okay, we're at 165 watts. Now I'm going to gradually increase the power to see where saturation begins. Saturation is normally found by input power and expecting the exact output. When we increase the input more than the output, it means we've reached saturation. Now at 310 watts, 335, 356, 356 seems to be, we're getting close to saturation now for this 400 watt amplifier. So I'm not going to push it any further than this. Now I want to look at the helix current. As you can see on the front display panel, it's showing 418 watts. which is not unusual because we believe this display panel is not as accurate as the power meter. It's also showing 4.7 milliamps. Although that's not horrendous, we like to see it a little low. And so it's a long way away from the danger zone, but we still like to see it a little lower than this. Now, what we have noticed in the past with this amplifier is that over a period of time, the power output will gradually slip. So I'm going to take it down a little now, and then we'll watch it over 15-20 minutes to see what happens. Okay, the power meter is showing 275 watts, and we're showing 318 here on the front panel display. So now we're going to leave this running for about 15-20 minutes. So just to recap, 4.2 milliamps helix, 318 watts, and we'll come back 15 minutes from now and see what reading we get. Now we're back 20 minutes later, and the output power is shown as 294 watts. That's quite a drop over a few minutes, and that's not acceptable for a production TWTA. So I'm going to turn this one off, connect the lower one, and we'll run through the same series of tests. By the way, one extra note, I'm going to turn this down to 0 output, put it into standby, but then let it run for another 5 minutes to cool off before I actually turn off the power. I'm just about to connect the second amplifier, but one point to note, these two plugs, here and here, are inhibit plugs. These amplifiers come from the factory with RF disabled. Without these plugs in place, it will never transmit. Continuing the test of this TWTA, I pulled another one off the shelf, and this one we're going to test and see if it works out any better than the first one did. Now, with all TWTAs, if they haven't been turned on for some time, we normally let them, I'm going to call it bake in. Very low power, let them run for a while. If there is any gas in the tube, this running brings the tube up to full operating condition. And this one has been running for about 4 or 5 hours today. I'm starting the test at 1 watt output and looking at the helix current. The helix current now is 1.7 milliamps, which is fine. And I'm going to gradually increase the power until I find saturation. Saturation is not the maximum output of an amplifier, but it is the maximum usable output of an amplifier. Beyond saturation, you're not getting a good clean signal, and consequently it really can't be used beyond that. So we're going to gradually increase the power and see where saturation is. I'm starting to bring up the power. I'm going to bring it up to somewhere in the high 100s, perhaps 190 watts. And then we're going to start looking closely for saturation there. In order to see the power increase in a more linear fashion, I've changed the display from watts into dBm. Now I am gradually increasing the input power level, and as I go up by 1 step, I should see 1 step increase on the output of the amplifier. There's the first step, second step. Everything is going exactly as it should do. We're reaching 250 watts. At 53.8, 53.9, we seem to have reached saturation. About 250 watts. Helix current is 2.5 milliamps, which is fine. So now I'm going to run the same test At the bottom end of this amplifier's frequency, 13.75 gig. Now we're coming up to the same power level, this time at the lower end of the frequency range for this amplifier. So I'm stepping through the input, watching the output, making sure that it stays in step. Again, at this frequency I've reached saturation, 53.9. Let's look at that in watts. 245, 246 watts. Helix current 2.6 milliamps. So this amplifier is in good condition. I'll wrap it up now and take the power off. That's the end of the test.